So I switched Skype. I'm opening also your presentation. If you want, I will try to synchronize this thing. If you prefer something else, please tell me what you prefer. Okay, can we start? So the people are here. We are going to start this panel with you. And then I will give the floor to another panelist. So please start talking.
First of all, thank you very much for the kind invitation. Apologies that I couldn't be there with you. This is a very nice conference. Let me introduce my colleague, Laura Garcia. I've been collaborating with for many years. I'm in Paris, and I'm associate professor of the School of Economics. The topic of the presentation is
Okay.
That details in the 90s, like were characterizing not only the but very directly to the personality were helped by marketing people and investigators along the highlight
Can you speak loudly, please, because we have difficulty, even though we have a lot of hardware around, but we can not hear you. Closer to the microphone.
Can you hear me better now?
Yeah.
We can deal one thing with the administration of the data in an electronic way. And we can take it to the next slide and help. After extended use of the details, the last 7 years or so, we can basically call it mobile health or health. Indicate the practice of medicine supported by mobile devices. These are most commonly referred to mobile communication devices like mobile phones or tablets nowadays or PDA earlier, along with health services and information, but also to affect an emotional state in a way, not only information. And there has been a lot of movement around monitoring what's happening, which I will come into later on my slide. So in the next slide is the need characterization record of the mobile devices. All the things that I mentioned. Then in between once more, these are needed to collect big amounts of data, such as data from the past, from the house, of the lifetime or daily activities, and the tools provide a lot of information about one's health and also one's life. If we can click as to why this is important. It is important because with such big amounts of data, we can make especially diagnosis certain symptoms, but also we can deal with patients caring for their own lifestyle. And thereby hoping to have an increased prevention of disease. This calls for an effective, more efficient, and sustainable healthcare system and saves a lot of time for the health professionals. If we think what and on the next slide, the trend shows that there is a big market around it as well. Has been estimated a lot of billions of euros around the European but also around the world. This is big again. From reports as early as 2014 or less that this is changing the outcome of life of our health involving around everybody now. Almost each one of us has got a smartphone. The health conditions and daily activities, even if we don't know, they are being monitored now. So how many steps we do, how many hours we sleep, what we have been dealing with in social media, what kind of things we have been declaring for our happy, anxiety, and stuff like that. So if we can click in this slide, industry technology is expected to grow and will grow annually. In fact, 3% every year. This represents. But it is being used in practice. The next slide describes basically what is happening just around the important practice of the least thinking point of that. They can do their own health records that is both or the points of care, this device. So in this device, just a smartphone, they have to build a whole platform for delivering mobile and location-based care. Okay. So all the clinicians do is have this, but also the patients use it for their own communication with system, appointments, consultation, advice before they visit, preparation for specific examination, stuff like that. So it's happening already. So the next slide, I'm going to take you to specific applications, like the aging, which is of course the challenge. The aging will be focused in the next slide. Comes from the fact that our ability to decline, this we can have with a clip exam, shows that already from the age of 30 something, our capacity to decline has less processing speed, intelligence, dropping, etc. You can click one phone, you will see the red line which indicates that if you don't behind this below this line, you are having symptoms of perhaps cognitive decline or stuff like that. So what we do about it? The next slide shows the big challenge that at the average age is increasing, we live more, but this is in fact if we associate with the fact that we give birth to children kids, the population is also aging as well. So this is becoming a huge problem in all societies around the globe. With the population age pyramid marking at the bottom of that corner being eventually changed already, and by 2060 they are expected to have kind of like pyramid used to be the old name. The next slide describes the cognitive decline, how much of political climate duration data and the rational life sometimes can be measured. There is no diagnosis at the moment with this, there is no pharmacological treatment, but there are things we can do perhaps non-pharmacologically. Physical exercise and cognitive exercise have been given recipe for training. Data is report already for changing plasticity, neural plasticity, thereby slowing down body rapid cognitive decline. And always can follow it, like the Asian keep saying about if we have a good health of our body and our mind, we have to change. The next slide, having a system which we can design like 10 years ago, in which we have software design exercises for this cognitive, physical training, and home monitoring system. And if you click on one, it can be given to elderly people, then the exercises to touch things. And if you click on one, these protocols remotely connected to the TV, allowing interaction of people to exercise. And we have specific protocols that we have provided. We can give you the whole physical training protocol, exercises to follow, interaction, and games sometimes make it a bit fun as well. We have given these, and we have tried various settings, healthcare centers, houses, senior centers, anything that you can imagine, with thousands of people, both of Greece and also from so, in the next slide, this hand-to-hand intervention regarding focus training, physical training. This slide, our action is for fighting the decline. And we have shown in the numerous studies that this is now becoming very powerful tool. So we have studied the effect. We are sure that with these kind of software details and detailed software, basically we can improve the health of the people. So,
okay.
In the next slide, dealing with these services, I think the slide was set up. If you click it, I want to emphasize in the LMCR network that we have now established. It's using the map, using the different sites all around the Greek domain of societies, different centers. We have numerous where people are using the system either from a center or from the phone, etc. to improve the health of this rate and delay the cognitive decline. And the slide for the next one, you can go to the next slide. You can quantify cells. With that slide, quantify cell initiative. Hello?
Hello, yes, I'm hearing you, but because it was too much time, can you finalize?
Okay, we have the quantitative cell initiative.
Okay.
Right? Quantitative cells, quantified cells is the collaboration basically is an initiative. Started something like 30 years ago, basically using mobile devices to monitor themselves, but also sharing the data with other people. So self-tracking basically self-tracking for one year. Self-tracking movement, but it's now appearing in numerous health e-health solutions and standard practice. So in the next slide, report, this monitoring of the daily activities like sleep, stress, daily measurement can actually be useful for doctors when they provide treatment. So they would love to have how people feel, how much people sleep, how much people walk, and to associate with how the treatment goes in time. Whether they are here in the but also if the effect this are associated with the kind of activities that the patients are doing. So in the next slide, I'm going to show you examples of this technology goals monitoring individual people, individual practices. This is the typical home in the Saloniki where we have being in back and publishing treatment, marketing, and all the devices. The next slide, see some of these results. So we have established technology back in 2014, 5 codes in living on their own. We have to monitor that we need devices, and other measurements. Here, set of data every day, monitoring and collect data by phone, and the data appearing here. The plot you can see for the video is the assessment of the pediatric development of the time. The bottom you can see the effect we exercise is the working speed of the individuals. We can monitor how fast they walk and their own goals. If ever associate this with kind of intervention, the subscription service on a diet, this one comes from you can see this change that arrow there. The second part of the red arrow shows the effect, the physical training the side that you guys are having in school. And therefore he is recording what speed by physically training his own goal. So it's a unique measurement of the status of using health intervention tools. One like one scope. This is one cluster. This is for completely their own. People completely their own.
Thank you, Professor. Thank you, Professor Bamidis. So I will, if you let me, I will send your presentation to the colleagues that are interested. And I will be very happy if you can come to some of our next events. Moreover, here in the audience, there are some of your colleagues that you know very well, colleagues from Technical University, from Medical University of Varna. So best regards from our audience and bye. Okay? Okay, thank you. Сега вече ще ми позволите, ще ме извините за това, че нямаше как да го прекъсна по-рано, защото беше по-продължително, отколкото сме се оговорили всички. So I want to excuse him about not keeping the time limit. So I want to continue our panels now. And next people who I really want to invite here. I want to show you and to represent first of all. So these are the people here. So please take your places here Professor Pavlov, Professor Bliznakova, and Assistant Dr. Железов. Please welcome. So first of all, I want to tell to all of you that these people are really brilliant, and I am really happy that they find me as a partner and as a person who they can work and discuss the topic. So it's really I'm very proud of this. And we discussed with them earlier how to do the things and who will be after whom. But maybe before this, I want to share several photos only about common work with them. And this is some kind of proof for it's not empty words and political words only. So actually we start communication with most of you after previous conference, or let me say during the conference, because Maureen was participated, and I was in the process of searching for a lecturer in neuroscience, and after several tries, successful or not, he decided to do this course for us. So the first thing that happened to me was that me, a professor in one university, I was lecturing from assistant from another university in very different field of study. And I really can say that studying things, learning things about medicine are more difficult than studying computer science, so I'm sure for this. Maybe for some of them, like for Professor Pavlov, he's going and getting deeper and deeper in programming, and maybe he's more successful in programming than me in medicine. But somewhere and someday we will meet, maybe. So this is the photo of the conference last year, and here are some pictures from our lab where we were in this course. So it was very happy, very funny. A lot of colleagues and students were invited there. So this is another place in order to prove that this was really true. It's not something like to say because we're in the conference. And at the end, after representing our group to Professor Pavlov, then he represented us to his head of department, Professor Tomchev. Now we have communication between two departments, and we are negotiating something to happen formally in September. So I am not authorized to mention these things in details. But let me say that in this group we have different meetings with this type of person, with our students in different master degree programs, and we have this thing that they will go and explain professionally, and I will not explain this. They will go and explain this problem professionally, and it took for us very much time to understand basic things in medical point of view. But when we think about all of this on the algorithmic and data point of view, actually, it's not difficult. It's normal case for me. It's not decidable at this moment, but it's not something like medicine. So it is something from our science. So that's why nowadays we promote people who have hybrid profile, because we now, even though with people here who are from data science group and they are now in this room, that the most qualified and the most well-payable people in the world, these are people who are analytics, data scientists, but who are also domain experts. So only to be analyzer is not enough to be successful. You have to be domain expert in some area in order to be more successful. So here are actually also some tryings for a lot of people. So we have two students that they have results on this data that colleagues prepared. They have tried some things, they have some results, we're comparing results. So this is very interesting for us, and this was the starting process. We started the process on this way, because I really think that the people have to start their research work informally, to receive some kind of results, to get some kind of culture of a team, ethical issues and emotion between them, and then to say, okay, we are ready to formalize, to receive money, to be whatever is possible, to write articles and so on. Now I will give the floor to one of them, to something with the text. Maybe it's not, okay? It's not, the text is not here, or there isn't any text. There isn't any text. Okay, sorry. This is probably the infinite. Welcome.
So let me tell you why haven't we cured cancer yet and what can we do about it. So let me use a totally plausible example. So imagine Earth and a random hardware mistake leads to a nuclear war. So everybody, almost everybody dies. So imagine the whole continents are shattered. So when we see Earth from space, we will definitely see changes, something bad happened. Then we will start searching for what exactly was the cause for this devastating damage. So we will need to zoom in order to identify in greater detail what happened. But eventually, we would have to zoom in so close in order to see that a single random trivial technical element malfunctioned, which led to signaling cascade, which then led to some errors, which led to the nuclear war, whatever. So now you can imagine how a large-scale damage can occur from something really small, something which is indefinitely smaller than the thing which we're observing from space. And that's the case with the human body. So what we as doctors are able to examine on the living patient is, so imagine looking at Earth from space. That's a really low resolution information. So we need to zoom in closer in order to figure out what happens with the organism. So this is a human eye. When we zoom in further, we start to identify specific structures. So the branching pattern of the vessels indicates the presence of health or disease. Then we zoom in further, and this is actually a live footage of the blood flow in a human capillary, and we see changes in the behaviors of cells. Then we zoom in further into a single cell. So that's an image of a single cell. The blue thing is the nucleus. Every single dot which you see is a specific molecular machine made up of different parts. So we need to zoom in further, up to the level of the molecules in order to examine their functions. So this is a motor protein that carries stuff inside the cell. If this malfunctions, it is associated with specific diseases. So let's imagine the scale. A single small element, a pin, for example, or whatever, bolt, compared to Earth, is the same as analyzing these molecules, and when a single molecule malfunctions, we have disease. So imagine the scale. We have 100 trillion cells, and each cell has roughly 100 trillion atoms, and more than 1 million different types of components. If one malfunctions, as I said, everything goes bad. So how can we examine this? How can we deal with this amount of variability? So I will show you two approaches. The first is the scientific approach. This is a piece of human tissue. This is an image of a human pancreas where the insulin is produced, whatever. The blue things are the nuclei of the cells. The big red thing is, if you've heard, the aisle of Langerhans, which produces insulin, whatever. So this is a typical image. This is a typical research image that we analyze in order to draw conclusions about what leads to disease. The problem is how to analyze this image in a way that can lead to statistically significant results. So we use different computational techniques in order to quantify cells. Problems are, however, as you see on the image below, that when nuclei are overlapping or we have different signal intensities, we have a hard time automating all of this. And since we need to analyze actually thousands, billions of cells in order to get statistically significant results, doing this manually is inefficient. not only inefficient, it doesn't produce any results. So let's see how modern computational methods can tackle this challenge. So the same image containing a lot of information can, if we develop good algorithms that can analyze the image, we can automate the process. So a computer can do overnight something which a whole laboratory of researchers needs to do in the course of years to produce the same amount of data. Another example, those are two cells which you see, and a computer can really segment and quantify different machinery inside the cell. So those are different machines within the cell, and we need to analyze and track their behavior over time to check what happens. Okay, so that was the first part. The second part is the clinical applications. The same thing which we do in the laboratories to discover new causes of disease, pathologists do to diagnose disease. The pathologist is the doctor who diagnoses your condition. So pathologists analyze pieces of tissue from the patients in order to determine what happened with their cells and to determine the cause of the dysfunction. So a single pathologist needs to observe hundreds of microscopic slides per day, and they can't afford to produce high-quality images because they don't have time. So they use images like this one, which contain too little information, and they need to infer from that. And now modern approaches utilize artificial intelligence in medicine that can help analyze these images and can rapidly increase the number of diagnoses that can be done in a single day. So that's something which people are working now at the moment. And I want to end with an insight which I had yesterday. This isn't the future of medicine, so the marriage of medicine and technology. This isn't the future, this is the present, and something cool. In this room, today, right now, we have all the talent needed to tackle these problems. So what we need to do is just work hard and together. Thank you.
Thank you very much. Probably you are thinking about how to go to be a student of Marin now. Okay, you can. And now, this topic will continue from Professor Pavlov from the same university, medical university. So please, welcome.
Hello. After what Dr. Железов did to introduce very good the problems that we face as researchers in a very specific field, although it is a very vast field of the medicine, I'm going to explain actually what we find out that we can do to tackle these problems. First thing was that we discovered that we cannot do this on our own, right? So, who am I? I'm a teacher in anatomy, and I am teaching anatomy and cell biology since 2002. And of course, a significant part of my doings is to torture students, as they can confirm here. Anyway, another significant part is the research, and we are interested in neuroscience mainly, and me personally, I'm interested in image analysis, both microscopical, the portion that Dr. Железов focused on, and also, however, medical imaging, because medical imaging is also a very important part of the medicine currently, not only for diagnosis, but also of research. Also, I have been blessed with other interests. I am very interested in data science because I wasn't very content with what I learned in university, so I just developed my interest in there, and from there I got to scientific computing and also interest in optimizing different processes between humans, so basically learning and research. Anyway, our work as anatomists is actually, although quite mysterious to most of the people, very straightforward. We are taking the human body, we take organs out of it, we slice them and look what's inside of it, right? Anything that small child does with their toys, etc. Right? Curious child. So we are slicing the brain, we are looking at it, we're using different imaging modalities, we're staining it differently so we can see what is there. And for a long time this was very useful because we didn't know what is there, we didn't know anything, we didn't know qualitative relationships, and basically we wanted to describe everything. So this was the descriptional phase of the science, and it was very important. Anyway, currently we are living in the age of the science-based medicine, and only the descriptive information is not enough. So we are going to the fact that we need data. Even more quantitative data from these images. Even more, current technology allows us to gather very quickly huge amounts of imaging data with different modalities, at different levels of research and of observation, and basically also we can relate this data with each other. Unfortunately, as medical doctors, we have no idea how to correlate data. Okay? This is a huge problem. So it may be seen very, very easy and straightforward, very short step from the imaging to the actual data that is produced and is analyzed and used for decision making. However, if things go smoothly, due to the problems that we already discussed, the most smooth algorithm that may follow, or more exactly a description of the process that takes during this, in between these two phases, seems like this, right? Basically, everything goes haywire very quickly. And this is the smoothest processes. So you must actually multiply this or lift to a power to understand how everything goes in our research. Although the graphics are very smooth and very precise, but we actually are not sure all the time what goes in between. So that's why I was very happy when we were contacted, when I was actually introduced to the team of Professor Momcheva and the students and co-workers and also, we started working on these problems. So one of the big problems in this particular tasks is the fact that taking part humans. So when a human is doing manual evaluation, we are subject to multiple biases which are basically part of our physiology. And one of these biases, I'll just give an example, one of these biases, you know this optical illusion, I'm sure, and still some of you may be not convinced that the green and the blue are actually the same color. And but they are, right? And you are well rested and are paying attention currently, because I hope I didn't talk too much until now. And still you're forced into this bias. Just imagine a person who was clicking on cells and, for, let's say, 3-4 hours, and before that they were teaching just how great the error would be in this particular moment. So this is what the reliability of our data is currently, and however, it's a very reliable data actually. Anyway, what is the solution? The solution is to reduce the human intervention, to automate everything, to increase the robustness of the algorithm against fluctuations in the experimental conditions, to cut the parameter choice steps that are made by the human. And of course, this will lead to increased reproducibility, reduce processing and analysis time. It will increase reliability, reduce cost, of course, both in time and in real money. And of course, will make our students and doctor students happy, because actually they have to do this tedious task all the time. Anyway, we had a very significant success from this collaboration, which I'm not going to go into detail, and this will be explained in much further detail by other colleagues from this informal currently group. But I want to focus on our plans for the future. Basically, what we want to do is to be able to select cells and quantify them automatically, and then use this data to make decisions based on real scientific data mining algorithms. What we plan, currently we had a very successful informal work, but it is time to formalize this, and we have a very good opportunity because the Medical University of Varna had a very good start with their research institute, and in this research institute is actually due to the fact that they won one very huge grant from European Research Area. They're expanding, so we will be applying for the creation of a multidisciplinary image analysis research group, which will basically, from this group, will benefit most of the divisions of this research institute. This research group the idea is that it will contain both biomedical and data science and development divisions, with of course, in the biomedical divisions will be specialists which are specialists in histology, in pathology, medical imaging, in microscopy techniques. In the data science development, of course, we need people which are good in numerical analysis, data science, machine learning, etc. At some point of time, we probably will want to invite also people which are specialists in optics and imaging and physics of light. But what are the goals of this group? Mainly, we want to expand the imaging capacity that we have currently. We want to improve the existing algorithms and want to adapt algorithms existing in other fields which we do not know about, but probably may be very useful to us too. Of course, we might be able even to develop new algorithms and approaches to this science, and the most important goal would be to translate all this work into something useful, into the diagnostic everyday medical practice, not only to use it for research. And why not develop even novel imaging modalities, because this happens all the time, every day actually, all over the world. What are the immediate plans? Of course, our immediate plans is to turn this task of creating data from imaging into a walk in the park, which won't be easy, but I am sure that it can be done still can be done. Another plan that we have is we were contacted recently by a group in Switzerland which are trying to correlate MRI imaging data with histology data and basically to develop algorithms to receive high definition information from in vivo MRI imaging. So we are looking forward very much for this collaboration. This will be one of the projects of this group that we are talking about. Of course, we also have plans to develop, this is an ongoing project which is currently on hold, but still for automatic measurement of supraepicardial adipose tissue on CT scans, or automatic quantification of plaques in multiple sclerosis on MRI series. But so basically, we want to expand into all levels of definition in the vast field of biomedical imaging, and to be able to implement data science into our everyday work. So I want to thank you very much for your attention.
Thank you very much, Tony Stoyan. I want to share also that if you people who don't know us want to join us, welcome. We need a lot of workers who we can teach how to do basic things, and you will do dirty work for us. This is a normal way of how to do science in the world since the beginning of the science exists. It's nothing wrong with this, because participating in such type of teams, you will learn a lot. And also, we are preparing 2 books about programming in Python for special purpose for image editing and also analyzing. So if some of you colleagues want to join, please, people from companies, if you want to join, please welcome, join our efforts, our groups. And the good news is that this group will be formalized in September. Now I want to give the floor to Christina. And Christina, let me firstly introduce you. So she's working in Technical University Varna, and when he comes back to Varna from Greece, that's why she is friend with Professor Bamidis. She brings her huge expertise in Varna. So we have a very, very good scientist in another university. So let's do not quarrel between universities. Let's co-working together on the huge topics. Because, sorry for that introduction, but because when some of us feels bad because of some illnesses of his parents or his relatives, he starts thinking that he can use his knowledge for science, for things that are for human beings. So we can start writing algorithms, doing this for competitions like you, without no effect for something benefits for the society. And it's very good to go in a study group where you can be involved to help to some people for the human development. So please, first of all, I want you to share with people your specialty, because actually it's very interesting also.
I'm a biomedical engineer.
Okay.
So my name is Kristina Bliznakova. I'm probably one of the very, very few biomedical engineers in Bulgaria. I graduated in the University of Patras, and Professor Babidis was my teacher also in the course. So it was almost 18 years ago. So I came back to Varna with Maria Curie scholarship, and I'm a holder of Maria Curie grant for contribution of science to society. And thank you again for your very nice invitation. So I hope that we'll start collaborate with you and your team, since we already do very, very good collaboration with Medical University of Varna and with the hospital, the University Hospital. So this is the team. Just few people, but very important. So we have 3 biomedical engineers, all of us graduated in University of Patras, and we have software engineers, physicists, and behind this group are the people from University Hospital of Varna who provided us with the data. So we did really very good job. So now I will present you this marriage, as my colleague said, between universities, hospitals, and industry. So the results. So maybe you know we are working in the field of breast imaging, and we are looking for new, radically new breast imaging technique that may screen the cancer as earlier as possible. So to do this, we needed really realistic tumor models, and to have such realistic tumor models, we needed data. So in Bulgaria, we got help from University Hospital Varna, from the team of Professor Radev Bulyashki. So within the frame of a European project Maxima, so they provided us with CT data from breast cadavers, and based on these CT images, we did segmentation, image processing, and by using image processing techniques, we managed to extract realistic tumor shapes. Also, we got data from Alexandrovska Hospital in Bulgaria, and also from City Clinic from Sofia, and also data from Belgium with our partners. So the team of software engineers, they did software. With this software, we managed to extract realistic tumors. And we needed these tumors in order to compare at simulation level what is the advancement of the proposed new imaging technique for screening the breast. So we also advanced a lot with modeling. So we also did a lot of modeling of such tumors from data. We are also very good in modeling techniques. And at this point, we are trying to verify the different models with our physicians in the hospitals. How realistic are they? So all these, all these tumors and models are now placed in a Maxima project database that is built also together with industry. And now we just finalized yesterday the project with the European Commission, so we can open this database officially to researchers and other institutions. So we can use data free of charge for research purposes. So I just can share with, for example, with a study we did with the GE, for example, General Electric, with their research team. So we have the breast as realistic as possible, and we just took one of these breast models and imported in the breast model. So we this is how the model looks like, and the slides, and then we did the comparison of, for example, of computation of mammography and the new proposed technique called phase contrast imaging. So this is now under implementation. Also, now we have everything in such a level as computational models, and to test a technique, a new imaging technique, we cannot use the women to expose them. So the best way is to now to prepare realistic physical phantom. So we had a big challenge in preparing such a model, because you know, the printing techniques, I saw some printers, we already have formulas since 2015. So that time there were no representatives for Bulgaria, so we bought it directly from England. But the problem with, until even last 6 months, was that these printers, they use just 1 or 2 materials to print such physical phantoms, and that's not enough. And now, together with cooperation from a small medium enterprise from Greece, we are developing a new technique for printing directly from CT image, directly the breast. And even now we are presenting the results. So your model, we have the model, for example, realistic, and then you can do and you can prove your imaging technique. So still a lot of work in this direction. And finally, it is the collaboration to represent that you can use all these imaging techniques. And for our small patients, is turtle we did with our clinic for animals. So this poor turtle had a problem with the shell. So we used absolutely the same software developed by the team for image processing. First, we scanned the turtle using PET, using CT for animals, and then based on this, we did the segmentation of the shell. And this is interesting that we suggest, we suppose that the shell is symmetric, so we just use the missing part. For the missing part, we we took the right part, and then with a lot of imaging, image processing techniques, we managed to recover this shell. So then we printed with our fuse deposition modeling, one of our printers, and so this is the shell recovered. So I think that really we can collaborate a lot, not only with between universities, but I think industry and business. We should be involved very strongly in research.
Okay, thank you to Christina very much. So there was a month or two before in the next lab, one meeting with business, and there one of them say that there aren't any scientists around. We don't know what these people are doing, so I really invited them to come today and to see what type of people and researchers are there in the city. And I think that all of these people deserve your applauses because they are working really hard. Congratulations for all of us. And I'm really happy that this time we don't need to go to police, to regional medias to come to make one photo. So here we have a real person from real specialized media, from ICT media. So thank you very much. So, and because I'm really honest, I will tell you that several times we are giving our competition of data retrieving and analysis Queriada for awarding, and nobody awards us because they awarded other things. I will not mention which one in order not to say something wrong for another type of specialist. And usual explanation is that the people from some authorities and politics and companies, I mean another type of structures, not companies, they don't know what we're doing. And that's why, but we know, and we deserve their awards, please. And that's why what we have to do, we have to go to publicity over and over to explain that we're brilliant, we're really brilliant, in order to let somebody to hear this. And this is what we're doing today. And also, we know that if some of us is very good, it's not enough, because there is one condition how to evaluate professors, and one of it is he or she is created a new group, a new science branch of research, something new. And this something new, up to now, is not necessary to be created with robots, up to now. That's why we need to participate and to work collaboratively with humans. So I will close this panel, and I will give some announcements to the next one, that after the break we're going to start on time. And we will see some people from business who are doing their business innovatively because they are using research. And in one of the representation, for example, there is one funny title for this representation. And we have here some discussions in the department that we don't want the people, you and other people who are watching us now, to see that we are boring because we are professors. So I want to tell you that everything that we show now could be represented on this way. That's why Christina is doing this, I'm sure, in order to be recognized and understood by the general public. So of course we have to do this too. This is also a part of a science, because we know that big and brilliant scientists can explain very simple, very difficult things in a very simple manner if he or she is an expert. So thank you, and see you at 1:40.